Hello, this is numbers 8, 9, 10, and 11 from the AP Physics Summer Calculus Survey. So let's get right into it with number 8. So this right here has four terms that we need to take derivatives for in order to find g prime of x. So we're just going to do this one term at a time. And in order to really understand it, I'm actually going to rewrite the first term. So I have g of x equals, so I have 1 over the cube root of x. So hopefully you recall that if I have x in the denominator, that is identical to a negative power, and the cube root can be understood to be the 1/3 power. So I actually have x raised to the negative 1/3. So I'm going to just go ahead and rewrite the remainder of my statement here, x to the e plus e cubed. And so now I'm going to take the derivative of each term one at a time. So g prime of x will end up being, for the first term, I'm going to take the exponent, bring it down and multiply. So my negative 1/3 will multiply x, and then I will reduce this exponent, this power, by 1. So I will have negative 1/3 minus 1, or you can think of that as negative 1/3 minus 1 is hopefully equal to negative 4/3. So I'll go ahead and write that here. So that's my first term. My second term is e to the x. So e to the x is this funny thing to take the derivative of. In fact, the derivative of e to the x is quite simply e to the x. This is simply a fact that you should know if you have taken calculus or if you've looked at derivatives of exponential functions. X to the e, on the other hand, is a little stranger. So this is x raised to the e power. So this actually follows the same rule as the first term. So I'm going to take my e and use that and pull it down and multiply by that. So that is my coefficient. And then I'm going to take the power e and reduce it by 1, which we can only write as e minus 1. The last term is actually a constant. E to the third power is a value. And if you take the derivative of something that is a constant, you end up with 0. So there is no actual derivative for this last term. So my final function for g prime is this right here. For number 9, I want to find the first derivative of the function f of x equals ln of that quadratic. So I'm going to rewrite this to have it where I'm working. ln of x squared plus 2x plus 1, and I want to find this at x equals 1. I'm going to take the derivative first, and then I'll evaluate it. So taking the derivative of a natural log is 1 over the argument of the log. So the argument of my log is x squared plus 2x plus 1. And then I need to remember that this actually will require the use of the chain rule. So I have 1 over the argument, and I will multiply this by the derivative of the argument. So the derivative of x squared, bring the 2 down, x now to the first power. Derivative of the second term is just 2. And so I have 2x plus 2 times this 1 over x squared plus 2x plus 1. So now I can evaluate. So f prime at 1 is going to be 2 times 1 plus 2 over 1 squared plus 2 times 1 plus 1. So f prime of 1 actually ends up being quite simple, 4 over 4, which is 1. Moving on to number 10. Taking the derivative of exponential functions should be somewhat easy. So if f of x is equal to e to the 2 pi x, I'm actually going to just pull out this coefficient of x and make that a multiplier for my exponential. So f prime of x is simply 2 pi times e to the 2 pi x. The same thing is actually kind of true for g. I'm really just taking a look at this x to the 2 pi e and thinking of it as reducing the power by 1 and making that my coefficient. So I actually end up with g prime of x being equal to 2 pi e, because that is a constant, times x to the 2 pi e minus 1. Now 11 requires an antiderivative. So if f prime of x is equal to 4x plus 1, what did I need in order to get 4x plus 1 as a derivative? Well, there's a couple ways to do this. You can think of doing the reverse of what we were doing before. So if I have 4x and x is to the first power, I would actually want x to be squared, to go up 1 power, which would leave behind a coefficient of 2. Here, if I have a 1, that means I originally had an x raised to the 1 power. Now what's left over? Well, I don't know for sure if there was a constant, but I'm going to guess that there was. So I need this extra information in order to find that. So f of 1 set equal to 0 will be 2 times 1 squared plus 1 plus c, this constant. And so solving for c, I actually see that c is equal to -3. So my function f of x actually needs to be 2x squared plus x minus 3.